Hey everyone, and welcome back to this class, Deep Reinforcement Learning, Deep Learning in Python Part 7. In this lecture, we are going to summarize what we learned in this section. In this section, you learn reinforcement learning techniques that can be applied to any situation where you would use regular Q-learning or SARSA. And so while the examples we did were very specific, know that they are more like general tools that you can test in a variety of situations. Although it may not have seemed like it, we technically got some more practice with RBF networks as well, since that was the underlying feature expansion we used for this script. It is convenient that these kinds of details can be abstracted away, so that you can focus only on the new parts. First, we looked at n-step methods as a generalization of TD0. TD0 is a one-step return because it uses one sampled reward. But we saw that we can use any number of rewards in our calculation of the return. In particular, using n rewards gives us the n-step return. If we take n all the way to the end of the episode, we are doing Monte Carlo. Next, we saw that we could combine all the n-step returns up to infinity, and this gives us the lambda return. This is for the situation where we weight each n-step return by a geometrically decreasing lambda. We saw that by manipulating our expression for the lambda return, that lambda equals 0 corresponds to TD0, and lambda equals 1, which we call TD1, corresponds to Monte Carlo. We then looked at an online algorithm using eligibility traces that approximates online TD lambda. It is interestingly reassuring that the TD lambda algorithm looks a lot like the momentum update from deep learning. Think of these as new tools for your toolbox, like all the other algorithms you learn in this course. It's not guaranteed that any particular algorithm will work for your problem, but the more tools you have, the more things you can try, and the more likely it is that you'll come across a solution.